Okay, so this is going to be a quick video on how to plot space curves using MATLAB. The first thing I want to do is just get into like how to plot a curve in general, and then we'll look at it from a three-dimensional space curve point of view. Okay, so let's say I just want to plot the curve y equals like x squared, right? So y equals x squared should give me a parabola. So I have to get this into MATLAB so it will do it. So the first thing I do is I choose a bunch of x values. So I usually use capital X for this. And the way I get x to do this, so let's say I want to plot the x values from like, I don't know, -4 to 4, right? So I'm going to make a bracket and I'm going to say I want to start at -4. And then I make a step size. So I want my curve to be pretty smooth. So I'm going to use a pretty small step size. So I'm going to say, let's make the step 0.1 and then have it go to 4. Now, I'm going to do this once without the semicolon so that you see what happens. And then I'm going to redo it with the semicolon. So if I do it without the semicolon at the end here, I end up with this big long list of clutter, and it just made a list of all of the values from -4 to 4 at a step of 0.1. And if you look over here, it made a matrix that has 81 different entries, and those are those entries from -4 to 4 by step 1. I don't want this clutter to happen every time I do this, so I'm going to clear the console. I'm going to do this again. So I'm going to type the same thing in, but I'm going to put a semicolon. So when I do the semicolon, it suppresses the output to the console. And you look, that X still got formed with 81 different values, but it suppressed the output to the console. Now, I want to have Y be defined by those X values. So Y is going to be big X, right, squared. And I'll put a semicolon there too to suppress the values. So now I have another 1 by 81, what's it called? 1 by 81 matrix, right? So I have all the x values in a matrix from -4 to 4 with a step of 0.1. And then I have all the y values in a separate matrix from -4 to 4 with a step of 0.1. Now, I want to graph this. So I type in plot x, y. And there it is. There's my figure, and it makes the expected parabola from -4 to 4. What it's really doing is it's plotting a point every, like, what's the word I want to use? Every 1/10 of a unit, and it's kind of extrapolating to make the curve from there. So let's look at another of these just real quick. So I'm going to minimize the plot. I'm going to have x run from 0 every 10th. I'm going to have this go to 8 pi, semicolon, and I'm going to have y be the sine of x, of the big X, semicolon, and then I'm going to plot the xy, and if I look at my plot, there it is. I get my sine curve, right, running from 0 up to 1, down to -1, and it's doing it every 2 pi units. If I do this 8 pi, I should have 4 versions of the curve, so it correctly plotted the sine curve within the window. So this is kind of useful. Now, space curves plot, we're going to use space curves as a plot of a vector valued function, but it's going to have 3 values. Okay, so what we're going to do here is we're going to CLC, we're going to clear the console, we're going to clear all the variables, and we're going to start over, right? I also want to show you something else. If I do CLF and I go back to that plot window, it clears the plot. Okay, so that's how you get rid of the plot. So I'm closing the plot window, CLC, I'm back to square one. All right. So I'm going to work a couple problems from your problem set. The first one I think is number 1 in the problem set. The way that we handle this is that we first have to establish t. So in that problem, t, so I'm going to make a little t, is running from 0, and I'm going to keep that 0.1 distance to 10, semicolon, right? Now, I'm going to get an x, a y, and a z. X, according to this, is just t. Y is 2 minus t. And z is 2 times t. Okay, so y looks weird. Why does y look weird? Oh, okay, I got it. Yeah, y's fine. So I have a whole bunch of matrices here, right? So now what I'm going to do is I'm going to plot 3D. Aha. So we're changing the command word here from plot to plot 3D. And we're going to use X, Y, Z. And I hit enter. Well, it's not plot 3D. It's just plot 3. Haha. Sorry about that. Plot 3, X, Y, Z. Now, it looks like it just kind of graphed a line there, right? So if I go view, tools, that's right. I want the tools. I want to rotate 3D. Gives me the little rotation tool. You can get it from over here too. It's a little cube. And I can actually grab this thing and rotate it around. So it did in fact just graph that as a line. Now if you try to work that out as a space curve, it actually is linear. It's not very exciting. So what I'm going to do is I'm going to grab one that is a little more interesting here. If you look at the problem set, number 3 in the problem set is like much more interesting. So let's clear our variables, clear the screen, and clear the figure. Okay, so let's take a look at number 3. Now, number 3 is a little bit of a glitch in it that we got to contend with, but we can deal with this, okay? So if I let t be, like I did before, 0, and we're going to take a step size of 0.1, and then we're going to have this go to 2 pi, okay? So that's not so bad. I'm going to put a semicolon there so I don't get all of it, right? Now, the y is not a problem. Y can just be cosine t. Okay, so that gives me another 1 to 63 double. Z can be the sine of t. Okay, that's going to give me a 1 to 63 double. The problem here is going to be x. So like, if I just like make x equal to 1, like it says, well, what happened here is that when it lit up x, it just made it 1. So x is now a 1 by 1 matrix, but I need a 1 by 63 matrix. Okay, this is a couple ways of doing this. What I can do is just say let x be 1, and then add 0 times t. Okay, so that will take all the values of t, multiply them by 0, and then add 1, right? Now 1 is a 63, 1 by 63 double. So let's plot this curve and see what this comes up as. So plot 3x, y, z. And okay, now it didn't close all the way here, and we'll talk about why that is. But if I kind of move this thing around, this made a circle. And this is because y is equal to the cosine of t, x is equal to the sine of t. That should make a circle, right? Y is equal to cosine of t, z is the cosine of t. That should make a circle. And x being 1 gives me some interesting realities here, right? Because this is a circle where if you look straight down at x equals 1, I get a circle. I get like it's all on that plane of x equals 1. Now, that's kind of interesting. Let's play around with this. Okay, so why isn't this closed all the way? Because I had it count by 0.10. So it got to like 6.2, right? It said, okay, that's between 0 and 2 pi. And then went to 6.3 and went, okay, that's outside. So that's that gap between 6.2 and 6.28. If I had gone all the way to 6.28, it would have made a full circle. So let's try something here. Like if I make t equal 0.1 to, let's say, 3 pi, right? And then I redo x, y, and z, right, following that rule. So x, y, z, and then redo the plot. When I look at the plot, oops, oh, that's weird. Let's go back a minute, see what I did weird here. I see where I did it. Instead of using colons, I used semicolons for the t's. So that should be a colon. There we go. And a semicolon at the end. Oop, that's still not right. Colon. There we go. There it is. And then I redo x, y, and z. Okay, so I have 1 by 95 doubles. I do the plot. And there we go. There's the circle with no gap this time, because now it's gone 1.5 times around the circle and it's overlapped. Okay, so that's an interesting curve. Let's try this. Instead of having x just be 1, let's let x be t and see what happens. So we're going to reestablish x, and now we're going to replot it. Oh, so since the x value is changing, this thing is, as it's going around the circle, it's spiraling. So let's have t go, instead of to 3 pi, let's have it go to 8 pi. And then redo x, y, and z. And then replot it. Oop, something like, oh, I redid x with the old x. Let's redo x as t. There it is. And now replot it. There we go. And lo and behold, we get a spiral that goes 4 times because the sine and the cosine curve repeat 4 times between 0 and 8 pi. All right, so this should give you a good idea of how to plot space curves. There's a series of them in the assignments there. Try to plot as many as you can. Get a feel for how this tool works in MATLAB. And if you've got questions, either drop them in an email or start in a, do one of the drop-in times. All right, so there you go. Awesome.